Hey, hello everybody. This is going to be the review, step-by-step answers to midterm review number 2. So let's get into it. So we're going to have a cliff, and this cliff is going to be 8 meters high. And at the top of this cliff, we are going to shoot a projectile, and that projectile is going to have an initial velocity of 20 meters per second, and it's going to have a mass of 3 kilograms. And it says calculate the initial gravitational potential energy. And similar to the last one, okay, we're going to have, let me do a different color. That is going to be mgh, which is going to be 3 times 9.8 times 3 times a height of 8 meters per second squared, and kilograms, and that is going to give us 235.2. So we're going to call that 235 joules. That is equal to that gravitational potential energy. All right. What is the gravitational acceleration? Okay. Once the ball is in the air, there's nothing touching it. Therefore, there's no applied force, there's no friction because we're ignoring air resistance, there's no spring. So all we have is gravity. The force of gravity is pulling it straight down. And therefore, the acceleration is going to be 9.8. Okay? So our acceleration is going to be 9.8 meters per second squared. Now, remember that in this question, it specifically says that up is positive, and we know that this acceleration is going to be going down, so our answer is really negative 9.8. So when you're doing the quiz, make sure you pay attention to which direction is positive, and therefore you don't get messed up, because there will probably be a choice of 9.8 negative and 9.8 positive, and you want the negative one because in the question it said up was positive. All right, question number 3. If the angle is 30 degrees, what's the initial velocity in the horizontal direction? So essentially what we're asking here is, hey, how fast is it going that way? And in the next question, it's going to say, how fast is it going that way? All right, so basically we just have a little trig. We're going to have, this is 30 degrees. So this right here is going to be 20 cosine 30 degrees, which is 17.3 meters per second. 17.3 meters per second. And that's the initial velocity in the x direction. And we're going to get something similar up here. We're going to have 20 sine 30, and that is going to be 10 meters per second is equal to VIY. Okay, remember that the sine of 30 is a half, and a half of 10 is, or the half of 20 is just 10. All right, our next question. Now, pay attention to here, because now I'm basically saying that the angle has changed. If the angle was 0, okay, if the angle was 0, so we're shooting it straight out, what would the velocity be in the y direction? Well, if it's going straight out, the y would be 0 initially, okay? Now, over time, that velocity would increase as we're going down. You would have more and more of a component that's going down. But initially, it would be 0, okay? So the initial velocity at 0 degrees in the y direction would be 0 meters per second. And the next question, well, what if we were 90? What if we were throwing it straight up? Okay, well, if we were throwing it straight up, then the initial velocity in the y direction would be 20. Okay, so the initial velocity at 90 degrees in the y direction would just be all of our 20 meters per second. Next question. All right, now we are back to 30 degrees. What is the maximum height that the ball will obtain? Okay, there are a couple ways that we can do this, and I am going to do it both ways. All right. So we're talking about this point up here where it's curving. So remember, it's going to come around like that. So we know that our velocity in the y direction, right here at its maximum, is 0. Now it's still going to have a velocity in the x, which is going to be 17.3, but at the very highest point. Oh, sorry. Wait a minute. We're going to go all the way down to here, right? So we can say, hey, our initial velocity is going to be 10 meters per second, because that was in the y. Our displacement, we're started up here and we're going to go down 8. So that's going to be -8. Our acceleration is going to be 9.8. Okay, that is going to be down, and we want to know the height. Okay. Sorry, I'm kind of messing this up. We're looking for this h. So our initial velocity is 10 meters per second, and our velocity final in the y is equal to 0. Sorry about that, guys. And we are looking for d. We don't know what it is. We're going to end up using that d here in a second. All right. So now with these variables, we do not have time. So we can say v final squared is equal to v initial squared plus 2ad, and we want to know this d right here, which is really just the height. Okay, this final velocity is 0, so we're going to have 0 is equal to 10 squared plus 2 times -9.8 times h. So we're going to move this one over. -10 squared is equal to -19.6 h. -100 divided by -19.6 is equal to 5.1 meters. Okay. Now that is not our final answer. Our final answer is 13.1, because we need to add back this 1/8, because we're going to measure from the very bottom. Okay, so we're going to have this plus 8, and we're going to get 13.1 meters high. Now, we can use the equation for max height. Okay, H max is equal to VI squared sine theta squared divided by 2g. Okay, this only works on level ground, right? But if we were to kind of calculate it from here to here, then that height right there would be 5.1. And again, we would add on our 8. We would add on our 8 and get back to the same thing. Okay? All right. So our next, sorry about that. All right. How much time will it be in the air? Okay. Well, when we go to get time in the air, it will have also come down to be -8, and we will not know what that velocity is. And so we will not know the time. And that's kind of where I was getting to when I got confused on problem 7. All right, so now we can use the equation displacement is equal to the initial velocity times time plus 1/2 AT squared. Our height change is going to be -8. Our velocity initial in the y is 10, and our acceleration in the y direction is going to be 9.8 negative. 1/2 of that is 4.9 t squared. We can now set it up into the form of a quadratic, and we are going to get, and that was equal to 0. So now you can, this is your value for A, B, and C. And now you can say minus b plus or minus the square root of b squared minus 4ac over 2a. And when you plug all those numbers in, your time is going to be 2.7 seconds. Okay, it's I think it's 2.66 seconds. 2.67 seconds. I was just looking at our significant digits, and it would be 3. Let me double check this. And all right. Anyway, I think it's 2.67, 2.66. We're just going to go with that. Now, question number 9. Okay, so number 8. Time is equal to 2.67 seconds. Again, once you do that calculation, if it's a little bit different, it's going to be pretty close to that if it's not that at all. So number 9, 30 degrees. What is the magnitude of the ball's velocity in the vertical direction just before it hits the ground? All right, so it's going to come up here, and then it's going to be heading down. And now what we're going to do is we're looking for V final. We're looking for V final. So we do know it's in the air for 2.67 seconds, but we also know this distance. So we can do this in various ways. We can say V final squared is equal to V initial squared plus 2AD. We take the square root of that, and now we have V final. V final is equal to the square root of 10 squared plus 2 times negative 9.8 times negative 8. These two end up turning positive. So we're going to have 10 squared plus 2 times 9.8 times 8 gives us 256, and we'll take the square root of that, and we'll get 16.0. So our V final is 16.0. Now, my calculator just told me that it was positive 16, but remember, when you're taking the square root of something, you're going to get a plus or a minus. So we got to think about our diagram here. It started up and it ended up coming down here. So we said up was positive. So this 16 really has to be negative because it's on the way down. And so you got to be careful about which direction I say is positive. So look in the beginning and you'll see that. So the answer is negative 16. And okay, if you have an angle of 30 degrees, what is the magnitude of the ball's velocity in the horizontal direction just before it hits the ground? Well, the horizontal direction didn't change at all, right? Because there's nothing to speed it up or slow it down. In the y direction, it's gravity, but in the x direction, there is nothing to speed it up or slow down. That is, of course, we are ignoring air resistance, and we are. Okay, so the answer is going to be, okay, remember number 9 was negative 16, and for number 10, it's going to be 17.3 meters per second. That's the same as it was before. Now we're going to do question number 11. Okay, now what is the ball's overall magnitude when it hits the ground? So remember, if we look at this part right where it hits, okay, I'm going to kind of blow that up. Okay, so as that ball comes down and hits the ground, remember, we're going to have this velocity in the x direction, which is going to be 17.3. And we're also going to have this velocity in the y direction of 16.0. And we want this hypotenuse. We want that hypotenuse. And that hypotenuse is just going to be Pythagorean theorem, which is going to be the square root of a squared, 17.3, plus b squared, which is 16. Now notice here that even if we have negative and it gets squared, it's going to turn positive. And when we work that out, the square root of 17.3 squared plus 16 squared, and we're going to get 23.56. So 23.6 meters per second. Okay. Now, I think my initial choice was 23.9, 23.6. Okay, so if you're seeing a discrepancy, in the velocities. It could be which numbers you use to make the calculation. So for example, if we went back, I think the first time I did it, I used 2.7. So you could be slightly off. When it comes to answers for the midterm, I am not going to give you choices that are really close to each other to test you for rounding. Okay, so if you get 23.6 versus 23.9 versus 23.4, you're not going to have all those choices. So if you get something close, if you calculated 23.6 and the only answer was 23.9 that was anywhere close, go with that 23.9. If you're way off any of the choices, you want to double check, but you will see a choice that will say none of these. And my intention is not to purposely put none of these. But as you know, doing physics problems, it's really easy to mess up. And it's really easy for me to mess up when I'm making a test. So I'm always going to put none of these, okay, which is typically not going to be the answer, but it could be. So I'm kind of putting in a none of these as a way to kind of save a problem if I messed up. Okay, so we're going to have 23 point, we'll call it 23.6, 23.6 meters per second. Okay. At the end of this video, I'm going to go back and I'm going to edit that so you might see that answer of 23.6, even though initially it said 23.9. Okay. What is the ball's direction just before it hits the ground? Okay. So now we want this angle right there, and we have the two sides. Okay. So we can say the inverse tangent of the opposite side, which is 16, divided by the adjacent side, 17.3. And that is going to give us the answer. So inverse tangent of 16.0 divided by 17.3 is going to give us 42.76, so 42.8 degrees. 42.8 degrees, and that's below the horizontal. Okay, so we could also call that negative 42.8 degrees using the standard position. Okay, so number 12, negative 42.8 degrees. Okay. What distance measured from the base of the cliff will the ball hit the ground? All right. So we've actually done all the hard work here. We know that the ball is going to be in the air for 2.67 seconds. And we know that entire time it's going at 17.3. So our distance is equal to VIXT plus 1/2 AT squared. But remember, in the x direction, there is no acceleration in the x direction. So this just goes away, and we're going to have 17.3 times 2.67 and 17.3 times 2.67 gives us 46.2 meters. 46.2 meters. And right there, I calculated 46.7. It'll probably be changed back to 46.2 when you go back and look at it. All right. Now, if you were to shoot the ball straight out, then how long would it be in the air? Well, if you were to shoot it straight out, your initial velocity in the y direction would be 0. Okay? So you would essentially end up with a quadratic equation without having to do a quadratic equation. Okay? So again, we'll set up the values that we know. Okay? So even though we're shooting it straight out, it's as if in the y direction that we just dropped it. So its initial velocity in the y would equal to 0. Our acceleration in the y is 9.8, and our distance that it's going to go is 8 meters per second. Or sorry, just 8 meters. Now, if we look here, this would be negative and that would be negative, and we want to know the time. So we can say distance is equal to VIT plus 1/2 AT squared. So our distance is negative 8. This is 0 plus 1/2 of 9.8 t squared. But this is negative 9.8. So we're going to have negative 8 divided by 1/2 of negative 9.4 is 4.9. And then we're going to take the square root. Remember, those negatives cancel each other out. And our time is going to be 8 divided by 4.9. And then we're going to take the square root of that. and we're going to get 1.277 or 1.28 seconds. So our time is 1.28 seconds. That's if we were to shoot it. That is if we were to shoot it straight out. And now if we were to shoot it straight up in the air, okay, now that means this velocity would be 20, okay? So this would be 20 meters per second. And now we would say -8 is equal to 20t minus 4.9 t squared. We're back to a quadratic equation. And if we plug those numbers in, our time, I believe, is going to be 4.45 seconds. Now, even though there was a quadratic here and a quadratic earlier on the midterm, you are only going to have one quadratic. You won't have two. So either this question will be dropped or the other question will be dropped. But we end up getting 4.45. All right, so this 13 was 46.2 meters. 14 was 1.28 seconds. 15 was 4.45 seconds. 16. At what angle result in the greatest distance or range from the cliff? And in all cases when we're ignoring air resistance, 45 degrees. 45 degrees is going to give us our greatest distance. Whether we're on level ground or up in the air, the greatest distance is going to be 45 degrees. Okay, so and finally 17. If you're back to 30 degrees, how fast will the ball be going after 1 second? After 1 second. Okay, so we're going to go to this question or this equation where we want to know the final velocity. We know the initial velocity plus AT. So now our initial velocity in the y is 10 meters per second. Remember, going straight up. Our acceleration is 9.8, but our time is equal to 1 second. So now we can say V final y is equal to 10 minus 9.8 times 1 second. Okay, so our V final in the y direction is going to be 0.2 meters per second. Final velocity in the y. Now, if we look at the answer there, it says 17.3. So remember, it's essentially, it's going to take 1 second, about 1 second to reach the very top, okay? And at that point, it's still going in the x direction at 17.3. So even though it's still going slightly up, right, only 0.2, if we were to calculate the hypotenuse there, 17.3 squared plus 0.2 squared equals square root, that 0.2 is really not enough to make it adjust anymore. So once we took the square root, it's still going to be 17.3. Technically a little bit longer, but because of our significant digits, it would still be 17.3. 17.3 meters per second. All right, that is it for midterm review number 2. All right, take care. See you next time.